Whenever we begin our cybersecurity journey, one of the very first tools we learn is Nmap. Port scanning, service detection, operating system fingerprinting, NSE scripts. For decades, Nmap has been one of the greatest network scanners ever built. And honestly, it still is. Nmap is an absolute masterpiece of software engineering. But I want to be honest with you about the reality of modern infrastructure in 2026. Today's networks are not small. Organizations own thousands of servers, tens of thousands of IP addresses, cloud environments, load balancers. If you point a traditional stateful scanner at a massive environment, you begin to hit limitations. First, large scans can take a significant amount of time. Imagine scanning thousands of hosts and tens of thousands of ports. You're sending millions or even billions of packets. Second, modern enterprise environments have become extremely defensive. Intrusion detection systems, security monitoring platforms, rate limiting, web application firewalls, cloud protection services. Security teams monitor unusual traffic patterns continuously. To survive in modern environments, our reconnaissance workflows have evolved. Today, speed matters. And this is where a modern tool enters the picture. Meet Naabu, a modern high-speed port scanner developed by ProjectDiscovery. Unlike traditional scanners that attempt to do everything, Naabu focuses on one specific task: finding open ports. And it does that extremely well. Naabu is designed for large-scale reconnaissance, automation, bug bounty workflows, attack surface management, cloud environments. Security researchers and red teams frequently combine Naabu with other ProjectDiscovery tools such as HTTPX, Subfinder, Nuclei. Together, these tools create powerful reconnaissance pipelines. If Nmap is the Swiss Army knife of network scanning, then Naabu is the racing car. It focuses on speed, scalability, and automation. Before installing Naabu, we need to understand something important. Traditional applications usually communicate through the operating system's networking stack. Applications ask the operating system to establish connections. The operating system handles the packets. But tools like Naabu work much closer to the network layer. They send and capture packets directly. This allows extremely fast scanning. So before installing Naabu, we install the required packet capture library. The very first command I usually run before installing Naabu is this libpcap. But as you can see, we're getting an error. The package cannot be located. And honestly, this is one of the most common issues beginners face in Kali Linux. So why does this happen? Linux distributions maintain package repositories. These repositories contain thousands of software packages. Sometimes your local package database becomes outdated. The operating system knows the package exists, but it doesn't know where to download it from. To solve this, we simply update our package list. This command does not upgrade your system. It simply downloads the latest package information from Kali repositories. Once the update completes, our package manager now has the latest information. Now, while this package installs, let's understand what exactly we're installing. Libcap stands for Library for Packet Capture. This is one of the most important networking libraries in Linux. It allows applications to capture and analyze network traffic directly from the network interface. In simple words, it gives programs the ability to see packets moving through your network. Tools like Naabu operate very differently from normal applications. Your web browser uses the operating system to create connections. Your SSH client uses the operating system. Your FTP client uses the operating system. But high-speed scanners often need direct access to packets. They need to send packets rapidly, capture responses quickly, process thousands of packets simultaneously. This is where libcap becomes extremely important. In fact, many popular cybersecurity tools depend on libcap. Tools such as Wireshark, TCP-dump, Snort. In the next step, we'll install Naabu directly from the official ProjectDiscovery repository and begin our first high-speed port scan. Alright, now that all the prerequisites are installed, it's finally time to install Naabu itself. The command you see on the screen downloads and builds the latest version of Naabu directly from the official ProjectDiscovery repository. Unlike downloading precompiled binaries, this method compiles the application on our own system using the Go programming language. This ensures that we receive the latest features, improvements, and bug fixes. While the installation is running, let's understand what exactly is happening in the background. First, Go contacts the GitHub repository and downloads the Naabu source code. It then checks all the dependencies required by the project. These dependencies include networking libraries, packet processing modules, concurrency components, and utility packages required for high-speed scanning. The Go compiler then builds the entire application specifically for our operating system and architecture. Once the compilation finishes, the Naabu binary is installed into the Go binary directory and becomes available from the terminal. One of the reasons Naabu performs so well is because it is written in Go. Go provides extremely efficient concurrency, lightweight threads called goroutines, and excellent network performance. This allows Naabu to process thousands of packets simultaneously while consuming relatively low system resources. Traditional scanners often focus on collecting a large amount of information during the scan. Then allow other specialized tools to perform service detection, web analysis, and vulnerability assessment. This modern approach makes Naabu an excellent choice for reconnaissance, bug bounty hunting, attack surface discovery, and large-scale scanning environments. And as you can see, the installation is almost complete. In the next step, we'll verify the installation and perform our very first high-speed scan using Naabu. Perfect, Naabu has been successfully installed on our system. Now it's time to verify the installation by performing our very first scan. On the screen, I'm using Naabu to scan a target host. And just look at the speed. Within a matter of seconds, Naabu has already identified the open ports. The output gives us several important pieces of information. First, we have the target IP address. And next to it, we can see the open ports that are accessible on that system. These open ports represent services that are listening for incoming connections. The faster we can discover these ports, the faster we can continue our reconnaissance process. Finally, let's take a look at the available options by running the help command. This gives us the complete syntax, available flags, and advanced features that we'll be exploring throughout this video. Scanning a single host is useful for learning, but in real-world reconnaissance we rarely deal with only one target. During bug bounty programs, attack surface assessments, or internal security testing, we often have multiple domains or IP addresses that need to be scanned. Instead of running separate scans for every target, Naabu allows us to place all our hosts inside a simple text file. Here I'm creating a file called targets.txt, and each host is added on a separate line. Once our target list is ready, we can simply provide this file to Naabu using the list option. Naabu automatically reads every host from the file and begins scanning them one by one. And as you can see, the results start appearing almost immediately. Naabu quickly processes all the targets and identifies the open ports for each system. Now that we've seen how Naabu can scan multiple hosts, let's make our scan even more focused. In many real-world scenarios, we don't need to scan all 65,535 ports. Instead, we may only be interested in specific services such as SSH, HTTP, or HTTPS. Using Naabu, we can specify exactly which ports we want to scan. This makes the scan faster and reduces unnecessary network traffic. As you can see on the screen, I'm scanning only a few selected ports. And within just a few seconds, Naabu returns the results. The output shows us the target host along with the open ports that are actively listening for connections. For example, port 80 generally represents HTTP, while port 443 indicates HTTPS services. Now let's look at another very useful feature of Naabu, and that is CDN detection. But before we run the scan, let's quickly understand what a CDN actually is. CDN stands for Content Delivery Network. Services such as Cloudflare, Akamai, and Fastly sit between the user and the actual web server. Their job is to improve performance, provide caching, and protect websites from attacks. Because of this, many modern websites do not expose their real servers directly to the internet. Now let's use Naabu to check whether our target is protected by a CDN. As you can see on the screen, Naabu analyzes the target and identifies the CDN provider associated with the website. In our results, we can clearly see the CDN information being displayed. This tells us that the target is sitting behind a content delivery network rather than exposing its original infrastructure directly.